All right, well, here we go. We've got a great big night of graphing trig functions. And our focus tonight is going to be on graphing the sine function. So go ahead and write out our new equation for sine. And that's y equals a sine fx. Okay, now, we want to make sure we say this properly. So anytime you see the word sine, we're always going to say the word of after it. So this is pronounced y equals a sine of fx. These parentheses are telling us to use the word of. So before we actually graph the sine curve, we're going to talk about where these come from. So what we want you to do is real nicely draw out that unit circle. So I'll draw it with you. You can pause it, draw your own circle. And we want to make sure we label those points. So right here, we're going to label points and the degrees. This represents 0 degrees, and the coordinates on the unit circle are 1, 0. Up here, this point represents 90 degrees, and the coordinates are 0, 1. This point is obviously 180 degrees. Sorry for my sloppiness there. And this is the point negative 1, 0. And then I go back to 270. My coordinates are 0, negative 1. And then this wraps me back around to 360. Now remember, you can go around this unit circle as many times as you want. You can go forwards in the positive direction, or you can go backwards with a negative angle. Now, a couple other things we need to know before we can actually graph the sine curve. We need to remember that every point x, y, and we see this on our quizzes all the time, in trig is called cosine theta, sine theta. Okay? And now, the very last part is we're not going to talk in degrees anymore. We need to talk in radians when we graph trig functions. Okay, so we're going to make a table of values, and we're going to convert these 5 degrees into radians. So we'll make a note here. This is degrees, and this is radians. So at 0 degrees, you're still going to get 0 radians. At 90 degrees, okay, well, all I have to do is convert 90 to radians, so I just multiply by pi over 180. And I'll cancel real nicely. The zeros will cancel. 9 goes into 9 once and into 18 twice, so I'm going to say that's pi over 2. This is definitely something we want to memorize. 90 is pi over 2. At 180 degrees, I take 180 times pi over 180. Well, those cancel beautifully, so guess what 180 is? You've got it. It's just pi. At 270, so I'm going to do my 270 times pi over 180. My zeros are going to cancel, and I'm going to say 9 goes into both of those. It goes into 27 3 times and into 18 twice. So that's 3 pi over 2. Sorry, I don't know what's happening with my pen. And then I'm going to go back to 360. And I'm going to say times my pi over 180. The zeros cancel. Let's see, and I would say that goes in there twice, so I get 2 pi. All right, so let's go back to our unit circle, and next to all those degrees, let's go ahead and label the radians on there. So this was 0 radians, 90 is actually pi over 2, 180 is pi, and again, I'm just getting that from the table we made, 270 is 3 pi over 2, and if I go back to 360, this is also 2 pi. All right. Now that we've gone through that, we're actually ready to draw the sine curve out. So this is a big moment. Feel free to make a little drum roll for yourself here. And here we go. We are going to graph y equals sine of x. Notice I said the word of because of the parentheses there. Sine of x. And we're always going to give you a domain. So we're going to go on this one from 0 to 2 pi. Okay. Now we're calling these sketches, but they have to be absolutely perfect. Neatness matters. They have to be at the right height, at the right point, the right shape. So really take your time drawing these. So since I'm going from 0 to 2 pi, I'm basically going to draw my y-axis and then smack in the middle my x-axis. Okay, now I'm going to put the same tick marks on every single graph. And these tick marks come from these points. 0, 90, 180, 270, 360. They come from that unit circle. Now, the only thing is I'm not going to use degrees. I'm going to use the radians we marked. So right here is obviously 0 radians, and I'm going to equally space these. My first tick mark, so after, if you look at my unit circle, I go from 0. My next degree is 90, so I'm going to put my radians of pi over 2 there. Equally space your tick marks. If I look at my circle, the next number is 180, which is pi. Equally space your next tick mark. Again to the unit circle, 270, which is 3 pi over 2. Another equal space, and I go back around to complete the circle to 360, which we said was 2 pi. Okay, now these 4 tick marks go on every single sketch, and they need to be evenly spaced. Now again, I went from 0 to 2 pi because that's what the domain said. Okay, now graphing this is super simple. We're just going to go back to our little key here we made, and we're going to say, well, the x value is cosine, the y value is sine. Since I'm graphing y equals sine x, I want the y value at each of these points. So starting at 0 radians, the y value there is 2 pi, the y value is 0. So I'm going to plot the point 0 at 0. Now I'm going to go to pi over 2. Okay, I'm going to look at my point. My point is 0, 1. So the y value, I can circle it, is 1. So I have to go up to a height of 1 and put a nice point. Then I'm going to go to pi here, and I'm going to look at the y value. The y value is 0, so I'm going to plot 0. I'm going to go to my 3 pi over 2. I'm going to look at the y value, which is negative 1. So I'm going to carefully plot negative 1. And then I'm going to go back to 2 pi, which is here. The y value is the same as 0's y value, so it's going to hit at 0. Okay, so you've plotted the 5 points on the sine curve. Now, you have to connect them in a very nice, smooth manner. There are no sharp corners or cusps. It's a very, very smooth curve. So, watch as I draw, and then draw yourself. This shape is going to look almost like a frown. I have to go up to my max, don't go any higher than it, and come back and hit 0 again. Okay, that's one hump of the sine curve. Now I'm going to continue, so that was a frown, and I'm kind of going to change shape. I'm no longer going to frown as I connect these. I'm now going to make a smile, so to speak. And this is called one complete cycle of the sine curve. So let's go ahead and write that down. Right here, we have one cycle. All right, now there's a lot of information I want to add to this. So first of all, let me talk about this one cycle again. One cycle has a hump above and a hump below. Notice they need to be evenly spaced. This went up 1, this should go down 1. This x-axis should be smack in the middle. It should basically cut it in half. Another way to start this, thinking about this, is I'm going to talk through these points. Notice I start at 0. So I'm just going to make a note for myself. I hit a 0. Then I go up to my highest point, which I'm going to call my max. Then I go back to 0. Then I go down to my lowest point, which is my min. And then I hit 0 again. So this is one way to think about the sine curve, is to say to yourself, I have to go 0, max, 0, min, 0. Notice it hits every point. It doesn't skip a point. It doesn't go 0, max, min. It has to hit that x-axis again. 0, max, 0, min, 0. This section where it's frowning, we want to make a special note, and we want you to recall this as concave down. Okay, anytime you frown, you're concave down. In this section that's smiling, we call it like up like a cup. This is concave up. Okay, so you should have one hump that's concave down, one hump that's concave up. And it goes 0, max, 0, min, 0. Now, let's go ahead and talk about our domain and range. The domain for this graph, well, we said we're going to go from 0 to 2 pi, but in theory, this graph can go on forever. It doesn't have to stop here because you can go around the unit circle as many times as you want. And it could also go this way forever. So our domain goes from negative infinity to infinity. Now our range. Okay, so now I'm thinking y values. How low do you go? Well, the lowest height that this graph goes to is right here at negative 1. And the highest is positive 1. So in that order, I go from negative 1 to positive 1. And since I hit those points, we're going to use closed brackets. All right, now I've got 4 exciting new vocab terms for you, and we're going to use these throughout every problem we do from this point forward. So the first one is midline, and like you can probably guess, it's the line in the middle. Okay, so we'll get our vocab, out of the way, and then we'll apply it. Number 2 is the amplitude. This is your height from the midline. Now, think about your height. If you measure yourself, your height is always a what type of number? Hopefully you've guessed it and you said positive. So amplitude is actually the absolute value of A because we always want a positive number. Okay, so don't fall into any bear traps. Make sure your amplitude is always positive. Number 3 is the frequency. Okay, now here's where these two get, pretty intense here. Frequency is how many cycles you see at 2 pi. How many cycles you see at 2 pi. And the last one is period. And this is how long it takes to complete one cycle. Now, the period actually has a special formula, so I'm sure you've guessed it. It'll probably be on every quiz from this point forward, and that's 2 pi over f, which is frequency. All right, example number 1. We need to graph y equals 4 sine x from 0 to 2 pi. Now, notice they didn't put parentheses in, so put your own parentheses there. It's 4 sine of x from 0 to 2 pi. So before I begin, I need to first find those 4 terms we just talked about. So you can look back in your notes. The first one's the midline, which you'll see in a moment. I'm actually going to skip that one. 2 is the amplitude. Okay? And we said amplitude is the absolute value of A. Now, in the beginning of our notes, the very first thing we wrote down is we are graphing y equals A sine of fx. Okay, guess what the A stands for? Amplitude. It's the number in front. The f, the number with the f, is the x, is the frequency. Okay, so you don't have to guess it. They always give it to you. So if I just look, the number in front, think alphabetical order, the number in front is 4. So my amplitude is 4. And remember, it's the absolute value of 4, which is still 4. Then I need my frequency, okay, which again, you don't have to guess. They tell it to you. The frequency is the number with the x. Well, if you don't see a number in front of x, you always know there's how many there. 1. So my frequency is 1, and that means one cycle, whoops, C-Y-C-L-E, at 2 pi. I have to see one cycle when I get to 2 pi. My period, okay, is not in the formula. It's a formula I have to memorize, and it's 2 pi over frequency. So in this case, I'm going to say it's 2 pi, and I just said my frequency is 1, so my period is 2 pi. Now that you have those things, now you can actually graph the sine curve. Okay, so let's go ahead and graph now that we have that knowledge. We have y equals 4 sine x. And they told us we're going to graph from 0 to 2 pi, so I'm going to set up my picture the same way. I'm going to put those same 4 tick marks on every single one, equally spaced. Pi over 2, pi, 3 pi over 2, and 2 pi. Now guys, these are super easy. If for some reason you forget one, just think of this. This is 1 pi over 2, and 2 pi over 2, the 2's cancel and make pi, 3 pi over 2, and 4 pi over 2, and that makes 2. So you're just counting by pi's over 2. Anyway, let me go back, and we're going to graph 4 sine x. Now remember, amplitude is the height from the midline. Well, the middle of my graph is the x-axis. Okay, so it's telling me instead of going up to 1 and down to 1, my max is actually going to be 4. So 1, 2, 3, 4, and 1, 2, 3, 4. Okay, I have to see my frequency is 1 cycle at 2 pi. So that means I have to squeeze my whole graph in at 2 pi. So here's a little trick. In real light colored pencil, I'm going to make like a vertical line here, and I'm going to say, okay, my whole graph has to fit at 2 pi. And the period tells me my cycle is going to end there. So I just say to myself, from what we've talked about, the sine curve starts at 0, and it goes 0 max, 0 min, 0. That's what we talked about. So we're going to start at 0. We're going to go up to our max. We're going to hit 0 again. We're going to go down to our min, and we're going to hit 0 again. 0 max, 0 min, 0. So unlike the first graph we did, instead of the max being 1, our amplitude is 4, so our max has to go up to 4. And our min has to go down to -4. Make sure you have those 5 points before you sketch. Now it has to look perfect. Concave down like a frown and concave up like a cup. And there you have it. Y equals 4 sine x. You have what we've talked about, an amplitude of 4, height of 4. Our frequency is 1. We're going to see one cycle when we get to 2 pi, hump above and a hump below, and the period tells us it should end at 2 pi. All right, we're going to spice it up a little bit. For example 2, y equals 3 sine of 2x. And we'll keep the domain the same. We'll go 0 to 2 pi again. All right, so we need to list out our information. Our amplitude, okay, is the absolute value of A. Our A is 3, so our amplitude is 3. Our frequency, the number with the x. Our frequency is 2, and that means 2 at 2 pi. The frequency is how many you're going to see at 2 pi. And the period will tell you when to finish the first cycle. The period formula is 2 pi over f. So in this case, I have 2 pi over 2. So my first cycle has to end at pi. Once we have that, we're ready to graph. So again, 0 to 2 pi, so my x or my y-axis is going to be on the left. Real nice x-axis. Get your 4 tick marks labeled evenly spaced. 1 pi over 2, pi, 3 pi over 2, 2 pi. Okay. Now, how do you know how high to go on the y-axis? Well, you look at your amplitude. My amplitude's 3, so I know I got to go up to 3 and down to -3. Again, equally spaced. Now, here's where we have to be careful. The frequency. You have to see 2 cycles at 2 pi. Okay, so when you get to 2 pi, you have to see the sine curve twice. That means a hump above and a hump below 2 times. Now here's where the period comes in. This tells you when the first cycle ends. If you have to see 2 at 2 pi, then the first one has to end at pi, and that's what this is telling me. So place that vertical line right at pi. Your first cycle has to end there, and your second one's going to end at 2 pi. So in between 0 and pi, I have to get one complete cycle, and that means I need a hump above and a hump below. So let's use some common sense. It goes 0, max, 0, min, 0. It starts at 0, it ends at 0, in the middle it hits 0. And now in between these 2 points, I have to reach my max, and in between these 2 points, I have to reach my min. And our max is 3, and our min is -3. So again, I went 0, max, 0, min, 0. I had to stop, my period's pi, so I had to stop my first cycle at pi. So I'm going to carefully sketch that in. So concave down like a frown, make sure it looks down. Concave up like a cup, no sharp points, no corners. Now you have to draw in 2 because the domain said go from 0 to 2 pi, so we'll just do it again. I'm going to start at 0, it ends at 0, in the middle hits 0, and in between there I have to reach my max, and I have to reach my min over here. And again, a smooth curve, concave down, concave up. Now the one thing you got to make sure is that all the heights are at 3. Do they look like they're at 3? And all the mins are at -3. Make sure it looks perfect. All right, now this time I threw a trap at you. Y equals -2 sine of 1/2 x. So let's be real careful when we label our information. Our amplitude, somebody's going to fall for it. Somebody's going to say the amplitude is -2, but hopefully it's not you. The amplitude is not -2 because the amplitude is the absolute value of A. So the amplitude is 2. Remember, height has to be positive. The frequency, the number with the x, is 1/2, and that means 1/2 at 2 pi. And then the period is 2 pi over the frequency, so 2 pi divided by 1/2. Let me show you another way to think about it. We can change division into multiplication. So I change my division sign to multiplying, but then I just have to take that fraction and flip it. So I have a period of 4 pi. All right, so now I'm ready to graph this puppy. So let's be real careful. I'm going to go 0 to 2 pi again. And let's get our 4 tick marks on there. 1 pi over 2 pi, 3 pi over 2, 2 pi. All right, and I'm going to think about where this ends. This frequency tells me that it's going to, my whole shape, my whole cycle, I'm sorry, let me slow down. I have to see half the cycle at 2 pi. And I won't see the whole thing till I get to 4 pi. So when I graph this up to 2 pi, I should only see half the sine curve, not the whole thing. So I'm basically going to see one hump, not 2 humps. Now, here's the other bear trap. So I need you to star this in your notebook. And let's kind of underline that -2. That means instead of going up first, you're actually going to go down first. That's what that negative tells me. So normally sine has the max and then the min. The negative tells me to go down first. So if I were to graph it, it would look something like this, min, then max. All right, so if my frequency is 2 pi, I'm going to see, I keep saying that, I'm going to see half the cycle at 2 pi. So I only want to see half the sine curve, which means I only want to see one hump. Now, do I want to go up or down? Well, because that's negative, that's telling me I want to go down. So I know I'm going to start at 0, and I'm going to end at 0. So I'm going to start at 0, I'm going to end at 0, and smack in the middle I have to be at my min. So the middle of these 2 points is pi over 2. So I'm going to go down to -2 at pi over 2. And I should see just half the sine curve. Notice I won't see the whole thing until I get to 4 pi, which makes sense. And I went down first because of this negative. All right, on the next slides, you have to be able to write the equation given a picture of the graph. So we're basically going to identify the same 3 things we've been talking about. So the first thing is the amplitude. Okay, look at your height from the midline. Our midline's in the middle. How high and how low does the graph go? And it should be the same. It looks like it goes up to a height of 4. Now there's one catch there. Where did the sine curve go first? It went down first. So when I put it in the equation, I'm going to have to put a -4, even though I know the amplitude is 4. Okay, frequency. Can you tell the frequency from the graph? Remember, that's how many cycles you see at 2 pi. Well, does the graph go out to 2 pi? It does. I see a hump below and a hump above. So that is one cycle when I get to 2 pi. So I would say I see 1 at 2 pi. And that's all you need to write the equation. So I'm going to say y equals, and just catch it, it's going to start with a -4 because it went down first, the sine of 1x, or just x. Let's try another one. Okay, same idea. Let's write the equation for this. So the first thing I need is the amplitude. And again, that's the height from my midline. My middle is my x-axis. How high and how low should go the same amount. Looks like it has a height of 3. And notice it went up first, so it's going to be positive. Now my frequency. Can you tell the frequency? It's how many you see at 2 pi. Does this curve go out to 2 pi? It doesn't. It stops at pi pretty much. So look how much you see at pi. You see one cycle. How many do you think you'll see at 2 pi? Hopefully you've said 2. If you're not sold on that, we can use the period formula to figure it out, and sometimes you have to do that. So I know the period is 2 pi over f. And by looking at this picture, the first cycle ends at pi, so the period is pi. So pi equals 2 pi over f. And now I'm simply going to cross multiply and say pi f equals 2 pi. I can divide the pi's out. So I know my frequency equals 2. And I'll put it all together to write the equation. Y equals 3 sine of 2x. Well, for a real quick summary today, we've talked about y equals a sine fx, where a is my amplitude, and remember it's the absolute value of a because your height is positive. F is your frequency, the number with the x, how many cycles you see at 2 pi. Period is how long it takes to make one cycle. And the midline is just the line in the middle of the graph. Well, that was a big night, and we look forward to some good practice. See ya!